Good afternoon, everybody. So, in this geometry lesson, we're going to be talking about congruent figures. Now, we've been talking about transformations, and congruent figures uses transformations as its proof often. This is a way you're going to use this uh, definitely in high school geometry. Um, Sometimes in like graphic design applications. So I want to not only go through the definitions, but also I'm going to take one of the examples out of the textbook, which homework always says read these textbook pages, and do it live or our version of live, because I really want you to be able to see, what does that mean? What am I looking for? Now, this is a problem solving task. This is not a formula. You aren't going to be able to do the same thing for every problem. But I will give you some things to look for that will help you in your problem solving abilities. Okay. So to start with, just a few definitions. Okay. First of all, an equal sign with kind of a swirly line on the top, that means congruent. Okay. And a two-dimensional figure is congruent. Okay. So here's this word, congruent, to another 2D figure if it can be mapped to the other. So these two have to be, have to be able to prove how they're related or connected. Okay. With a sequence of rotations, we studied those. Okay. Reflections, we studied those. And or translations, which means it might use one of these, it might use more. Okay, notice all of these are rigid motions. We're using our rigid motions to prove that two things are congruent. So, for example, and this is going to be in the next example that we do in just a second, if I'm asking, is triangle JAR congruent to triangle, and these are the actual mathematical notations, is triangle JAR congruent to triangle LID? I'm asking if J matches up with L and A matches up with I, and R matches up with D with the same series of movements. One of them can't move 4 steps and the other one only moved 3. The amount of movement has to match. Okay? Note, amount and direction of movement has to match between coordinating points. Okay? Now, to answer these kinds of questions, okay, you are looking, you are investigating, and you are problem solving. You need to notice any rigid motions. This is a little bit of a detective discovery type activity. And here's an example. So in this example, okay, sorry, I have to go to it on my other screen as well. Okay, we have two triangles. Okay, they look like the little triangles from the old-fashioned game Asteroid. And I'm asking, does JAR become LID? Does J go to L following the same motions that would move A to I? Following the same motions that would move R to D. So that's what I mean when I say those have to be corresponding. Okay. Now, I'm going to tell you that this is an example. I'm not trying to trick you. It does. And I'm going to show you how this matches. Now, there's more than one way to get there. You could do this first part. You can switch the order of the two things I'm about to do. But the first thing I notice is that this, if R is going to match up with D, it definitely has to scoot over. So if it matches, and this is me investigating, it definitely has to scoot over. So is that even possible? Well, what if everything went right 4 and down 1? That took R to D, okay? And so I'm going to call this R prime. So first, I'm checking out right 4 down 1. And yes, this sounds like I'm playing some kind of a game. What if I took A and went right 4, 1, 2, 3, 4, down 1, and that became A prime? And what if I took J and went right 4, 1, 2, 3, 4, and down 1, and that became J prime? So now you're seeing where this labeling is probably kind of helpful. And I'm just going to outline this, right? Okay, so I took this one. Let me double check. 1, 2, 1, 2, 3, 4, down 1. Okay, 1, 2, 3, 4, down 1. Oops. I missed that part. Okay. It didn't, the shape looked wrong. And when that happens, check it out. See if you did something wrong. Okay. So that makes this R1. And I'll redo the yellow. Okay. And that's going to happen to you too. And if it doesn't seem quite right, double count, double check. Okay. So that's where I got that yellow. I scooted it over and I scooted it down. Well, now they're touching at this RD corner, and I know R and D have to match up. So that might be good. But what about A and I? Do they match up? Well, let's take a look. A is 1, 2 spaces off the x-axis, and I is 1, 2 spaces off the x-axis. Oh. L is 1, 2, 3, 4 spaces off the x-axis. 1, 2, 3, 4. So then we did a reflection across, and you always have to say which axis, x-axis. So by doing a translation and then a reflection, this triangle was able to flip to the spot of this triangle. Okay, this one is just going to take some exploring, some practicing. Several of the questions will ask, does this work if you do this? Some will ask, what could you do to get there? It is a problem-solving activity. Try it a couple different ways if you need to. All right, can't wait to see you guys soon.